crucial feature of organisms is the ability to respond to stimuli. So a stimuli or a stimulus could be classed as a type of change in the environment the organism's immersed in. The more complex the organism, the more sophisticated the ability for them to respond to stimuli is going to be. So if you look at a human example, they've got quite a sophisticated set of receptors which help to detect stimuli in an environment, and then they can reel on a message or response from the body. So if we're looking at the human body, the body contains numerous receptors, and the goal of these, or the role of these, is to detect both living and non-living stimuli, with the ultimate goal being so we can respond. So there's going to be a number of different, or there is a number of different stimuli which we might need to react to. Like I said before, stimuli being the plural, or stimulus, the singular. So a stimulus could be any kind of change in our environment, the environment that we're immersed in, that we might need to or want to react to. So the first of which is temperature. The humans need to react to temperature and temperature changes. So the reason is because humans become what we call hypothermic if they're too cold, to lose too much heat, or humans become hyperthermic if they get too hot. So humans need to operate at a pretty standard and stable temperature. So we can say that humans function best at 37 degrees Celsius. So we want to stay within that range, and we don't have a lot of room to move. Small changes, as much as sort of half a degree here and there, will start to have quite significant physical effects, and we'll feel those effects quite rapidly. So what we have is something called thermoreceptors, which sit throughout, more in our skin and throughout all over our body. We have thermoreceptors, which are a type of receptor which detect changes in temperature. So these thermoreceptors are going to relay messages via our nerves through to our brain, through our nervous system, to try and relay the message that we're either too hot or cold, and then our body can start to react. So these receptors are all kind of the first point at which our body will detect and then eventually be able to respond to a particular stimulus, so a change in environmental conditions. Another stimulus which we respond to is light. I've got pictured over on the left here. This is a bit of a complex kind of diagram of the eye and some of the inner workings of the eye. So I guess starting off with an interesting point is that humans can actually live in darkness. So we don't need light. We wouldn't die without light. Humans can live in darkness, but it would be hard. It will make our life a lot more difficult. Chances are, in complete darkness, we would probably die a lot sooner, because we wouldn't be able to respond to things that we see, which might put us in danger or trouble or kill us. So in order to be a bit more safe, I suppose you could say mainly, is changes in light are able to be detected by something called photoreceptors. And these photoreceptors are going to be located in the retina, see on our diagram the retina located here. What we can also see is at the back of the eye we've got an optic nerve. So this is what will eventually relay the information that the sensor picks up in the retina, the photoreceptor in the retina picks up. The information will be relayed via the optic nerve back towards eventually the central nervous system. Another stimulus is sound. We've got pictured over here the inner workings of the ear. So obviously the ear detects sound, and I guess an interesting point too is that our sound or our hearing depletes with age. So over time our hearing is gradually going to decline, our ability to hear is going to decline, and we're going to have poorer hearing inevitably as we grow older. So how does this work? Well, sound waves are going to hit the eardrum. These sound waves are going to be transferred to small bones in the ear. There's three main small bones in the ear. These are the cochlea, the stirrup, and the anvil. These are involved in taking these vibrations, so these sound waves, and then relaying them via a nerve to the central nervous system, where they can then be deciphered, and then we might get a particular response as a result of a particular sound that we hear. So sound waves hit the eardrum, then these small bones in the ear transfer them or help to sort of decipher them, and then eventually relay them via a nerve to the central nervous system. They're taking them from a sound wave into an electrical impulse. Our final stimulus we're going to look at is chemicals. So these are going to be detected by receptors in the tongue and nose. So here we're talking about our sense of smell and our sense of taste. So smell and taste actually work together. This is why when you block your nose when you're eating, I think it's a potato and an apple, you find it very hard to find the difference between a potato and an apple with your sense of taste but not your sense of smell, because they work together. So these type of receptors are called chemoreceptors. These chemoreceptors work to protect us from things like bad food that might make us sick, or also dangerous substances. So we don't ingest or come into contact with something that might be taste bad or smell bad, and therefore we might pick that up as being something that could hurt us or damage us. So those are four main types of stimuli that we need to respond to: sound, chemicals, light, and temperature, and a number of the different types of receptors that help to be able to decipher those stimuli in our environment.